welcome and thanks for joining. So today's presentation is going to be all about the study on embodied carbon and new building materials. Basically, the study was carried out by a team that was led by Arup over the last kind of 2 years, ending in June. And essentially, all of the outputs of the study are going to feed into EDGE version 4. And so this presentation is really meant for quite a wide audience. So those, professionals working in the built environment sector, but, covering industry, policy, academia, etc. Obviously, it'll be most relevant to those who have an interest in sort of embodied carbon and low carbon construction, particularly people that work with EDGE. So, EDGE users, developers, auditors, certifiers, and the like. So moving on to the next slide. So today we're going to hear from a few different people. So Ellen from DESNZ, she's the MAGC program lead. Just so for those of you who don't know, MAGC stands for Market Accelerator for Green Construction. So Ellen's going to talk in a second. Elaine from IFC is the MAGC research lead, and Adalberto, also from IFC, is the MAGC technical lead. And then my name is Matthew Monroe, so I'm from Arup. And I was the MAGC research project coordinator, and I'll do most of the speaking during this presentation to cover kind of the details of the project and what we found. So moving on to the next slide, I just wanted to really take a moment to acknowledge the project delivery team who kind of have done all the work to deliver this project. I'm not going to introduce all the people that you see on the screen, but I just wanted to kind of draw your attention to the fact that we do have a large team of sort of product LCA, buildings LCA, and materials experts all working on the study. So I'm just going to put their names on the screen for a moment and just say a big thank you to them. And also just touch on the fact that, as I said, the study was led by Arup, but we had team members from Construction LCA, EBP Chile, Cintali, and Building Transparency all contributing to the work as well. So the agenda for today, so we're going to spend about 20 minutes covering the kind of context to kind of the MAGC research program, some definitions, that kind of thing. And that's where you'll hear IFC and DESNZ colleagues speak. Then I'll spend some time talking about the scope and approach of the embodied carbon study. And then I'll get on to the kind of main study findings where we talk about the embodied carbon results and also kind of insights on how to reduce embodied carbon. Then I'll just briefly touch on kind of next steps before finishing with about 30 minutes or so for Q&A. If anything, I think we'll probably finish a little bit early. And in terms of questions, so as far as I understand it, everyone except for the panelists will be muted throughout the entire session. So we just ask that you post any questions that you have into the chat, and then we can address them all at the end of the session. So yes, moving on to context. So I'm going to start with some definitions of key terms. So the first one is life cycle assessment, or LCA. And this is a standardized scientific method to evaluate the environmental impacts of a product or process across its entire life. And then a whole life carbon assessment is a comprehensive evaluation of all greenhouse gas emissions associated with a building or a built asset throughout its lifespan. So basically what EDGE is doing, or part of what EDGE is doing, is carrying out a whole life carbon assessment for buildings. Embodied carbon, this is the GHG emissions associated with the entire life cycle of construction materials and products, but excluding the operational and the user carbon. And then upfront carbon is the emissions associated with just the initial construction phases of a building. So it's very similar to embodied carbon, but it's just up until the point where the building is constructed and ready to be occupied. So it includes things you see there like material extraction, transport, and construction. So that's modules A0 to A5, or commonly people would refer to A1 to A5 as the kind of upfront carbon scope. And so this diagram, many who work in this industry will be familiar with this diagram. It basically shows the kind of whole life cycle assessment information. The focus of this study is this gray box. So this is the embodied or whole life embodied carbon. It includes both the upfront carbon, which is the carbon up until the point the building's built, but then also things like use, maintenance, repair, replacement, refurbishment during in use, which is the blue, and then end of life, so the deconstruction of the building, transport of waste, waste processing, waste disposal, is everything included, embodied carbon. And then, as I said, this purple box, A0 to A5, is the production of materials, getting them to site and installing them on site. That's upfront carbon. Two more definitions. So firstly, Portland cement clinker. So this is the chemically reactive material that forms the base of Portland cement. And Portland cement is made of around usually 95% clinker and 5% gypsum. And Portland cement is the kind of most common form of cement used globally. There are many others, and we'll kind of get on to more about that later in the presentation. Supplementary cementitious materials. So these are other materials that are basically used to replace clinker and cement. So these are materials like fly ash or slag, also known as GGBS, which are added to concrete to improve its properties and or reduce its carbon footprint. So these are really important for the concrete embodied carbon section. And I just want to touch on the kind of big picture scale of embodied carbon in construction. So on the left-hand side graph, you can see that the buildings construction sector accounts for about 37% of global carbon emissions. So it's really significant at a kind of global level. And then on the right-hand side, you can see that the orange segment of the graph is basically showing how embodied carbon is becoming a growing share of the total building sector carbon. It's projected to reach nearly 50% of building sector carbon by around 2050. And this is really because, in a lot of countries, we're seeing grids, electricity grids decarbonize, but things like steel and cement production are not necessarily decarbonizing as quickly as the grid. And so that's why the embodied emissions are becoming a sort of growing share of the total. And of course, most of those on this call will be kind of aware of the urgency of addressing climate change. And so this is why embodied emissions from buildings are a really high priority for policy and for green finance. So next, I'll talk about Market Accelerator for Green Construction Program. So this is a program that's funded by the UK government, the Department for Energy Security and Net Zero, and it's delivered by IFC. And I'm going to hand over now to Ellen from DESNZ, who's going to speak more about the program.
Fantastic, thank you so much. And hi everyone, it's really brilliant to be here. So my name's Ellen Coverdale, I'm the programme lead for the Market Accelerator for Green Construction. Matthew very nicely called it MAGC, we like to call it MAGIC, and we're based in the UK Department for Energy Security and Net Zero. So thank you for joining us today. So yes, I'm just going to give a bit of background on the wider programme. Running since 2018, it's funded by the UK's International Climate Finance, delivered by IFC. It's worked in 24 countries across Latin America, Asia and Africa, with blended investments in 9 of those countries. So MAGIC aims to drive the financing and construction of greener buildings through technical advisory support to financial institutions, blended investments to support construction, capacity building, and the continual development of the Excellence in Design for Greater Efficiency, or as everyone knows, the EDGE Green Building Certification Platform. So the general theory of change for MAGIC is that we expect that all those different components will then raise the awareness of the commercial case for green buildings and build the capabilities of public and private actors to deliver on it. That then creates a market where green buildings are valued and widely adopted, and that market can then be supported by readily available financing and robust policies. And as Matthew's just said, this really matters given the emissions in the building and construction sector being about 1/3 of global CO2 emissions. So MAGIC's helping to tackle climate change by locking in low emissions through efficient building design, but it also has a number of co-benefits, including lower utility bills, resource efficiency, and green economic growth. There's been really good progress since 2018. So 29 MAGIC deals have catalysed nearly $3 billion from others, and EDGE certification has been applied in over 170 countries. The research component of the programme just helps us to step back and reflect on what's working, where we see impact, and where we might need to adapt. It also helps us to understand value for money of different interventions, and it can inform future funding. I'm actually just back from joining a research mission to Colombia to better understand a different strand of the research programme. And through that, I learned so much, and I feel very confident that I'm about to learn so much more through this webinar. So I just want to say a really genuine thank you to everyone in the delivery team who's informed this research, and I'll pass back to Matthew.
Thanks, Ellen. So on to the next slide. I'm going to really briefly touch on the slide just to say that the MAGC program has kind of 4 main components. So there's the concessional blended finance component, advisory services, the EDGE app itself, and then this research and evidence program, which so the study that we've undertaken is part of this research and evidence program. And so now I'm going to hand over to Elaine from IFC, who's going to talk more about that program.
Thanks, Matthew. Hi, everyone. Really nice to be here. My name is Elaine Reinck. I currently lead the MAGC research program on the IFC side. The program has basically 4 components plus a cross-cutting component on dissemination and outreach. So this webinar is conducted under that outreach component. We conduct these types of webinars, in-person dissemination events. We develop publications to increase awareness and the understanding on the topic of green buildings and eventually motivate behavioral change amongst various stakeholder groups. The first component of the research program was the stakeholder assessments. They were conducted in 7 countries to look at perceived motivations, decision-making criteria, and obstacles related to the green building market among different stakeholder groups. These were completed between, well, I would say around 3 years ago, and they are available on the EDGE Green Buildings website. And the second component was the MAGC market maturity assessments. So they characterize the state of the green building market across 13 countries, both before the MAGC program was implemented and now at the end of the first phase of the MAGC program. So the set of 13 baselines is already available on the EDGE Green Buildings website. They were conducted between 2019 and 2023. And the end lines are ongoing at the moment. The first 3 countries which will be available are South Africa, Vietnam, and the Philippines. And the remaining 10 countries will come a little bit later towards the end of this calendar year. Then I'm not going to talk much about the embodied carbon study because we're going to hear a lot about that today. On to the EDGE impact evaluations, or we also refer to them as the smart metering studies. They're really the centerpiece of the research program. These are 3 big studies to measure the actual energy and water consumption of EDGE certified green buildings compared to conventional buildings and the EDGE model in residential areas in 3 emerging markets, Colombia, Indonesia, and South Africa. These are ongoing, and the studies results will be published in 2027. That gives a good overview, and back to you, Matthew. Thanks.
Thanks, Elaine. So moving on to now talking about EDGE version 4, and so Adalberto is going to jump in and speak about EDGE version 4 generally, and also how this study links in.
Thanks, Matthew, and thank you, everyone. So this is Adal. I'm leading the technical development of the current version of EDGE and the upcoming one. And I always say that I have the best job in the world. So we have, on one hand, great teams, professionals creating data and information for us. And on the other hand, institutions willing to support the development of initiatives like EDGE. So then my job is to glue these 2 and then see how we can better deliver the outcomes of studies like this for people to use and to make more informed decisions in terms of embodied carbon. So just briefly touching on EDGE version 4, the goal is to have a version that has increased calculation capabilities, but with keeping the same ease of use. So because part of the success of EDGE version 4 has been that, well, of EDGE in general, has been that it is an app that is easy to learn, easy to use, easy to understand, and most importantly, to create value or to out of it. So EDGE version 4 will have, other than 4 components: energy, as what we know, energy and carbon emissions combined, water, materials, which is part of for which embodied carbon of this study will be used as the base for it, and the resilience component. So there will be a soft integration with building resilience index for projects being certified under EDGE version 4. Also, we are preparing a more detailed operational stage program as well for existing buildings. But overall, EDGE version 4, it is a evolution of all the different client demands, requests, and the feedback that we get every day from our global user base. And we have currently around 20,000 different users using the app per year. And that's something that the current infrastructure was not prepared for back in the time when it was designed. So now we have a nice problem to have, which is to solve a growing demand for people looking for simple but intelligent tools for designing green and resilient buildings. If you, on the next slide, we can see that the pillars, how I call them for the development of EDGE version 4, are 4. One of them is a full methodology update, making sure that we are using the latest standards available out there. It's a combination of standard, ISO, ASTRA, CIPSI, and other standards that we are putting together in the form of a calculation engine. On the baseline, we will be adopting a building energy code regulation and adoption study that has been done by some of our colleagues from the World Bank as well. So we will have a revised baseline set of assumptions, a embodied carbon study, which is the work that Matthew will be presenting, which we are quite excited about. And this embodied carbon contains more information that we currently have in EDGE version 3. For example, the addition of A4 to A5, which is transportation and construction, so emissions associated to transportations and constructions. And finally, a full cost calculation engine revamp for improved decision making. So we will be providing more webinars around EDGE version 4 in the future to explain each of these. This webinar, it corresponds to the third element, to the green box. And this is one of the 4 that we will be having, well, of many, but of the 4 in the context of the pillars that we will be having for you all. So you're all invited to join us in the series of webinars for EDGE version 4. And yeah, thank you, Matthew. The floor is yours.
Thanks, Alberto. So now moving on to the MAGC research embodied carbon study scope and approach. So basically this project has delivered 3 main outputs. The first is material carbon estimates. So what we've done is develop regionalized or region-specific embodied carbon estimates for structural building materials. So that's concrete, steel, timber, and bamboo. The second thing is we've developed guidance for EDGE users on basically how to include less carbon intensive materials on their projects. And then the third thing is updated the EDGE materials reference guide with new structural assemblies that basically EDGE users will be able to select from when using EDGE. And at a high level, the kind of overarching aims of the study for the product LCA, well, first of all, to produce high quality data. It's really important that we have robust embodied carbon estimates to underpin the LCAs that are being done in EDGE. Second thing was to have full life cycle coverage. So EDGE version 4 will actually cover the upfront carbon, so that's modules A0 to A5. But the idea is that future versions of EDGE might expand to cover the full life cycle, modules A to C. And so we wanted to make sure that the data we were developing was future-proofed for any kind of expansion of scope in the future. The third thing was to include more lower carbon building materials. Obviously, EDGE users need ways to reduce embodied carbon on their projects in order to meet their targets. And then the final thing was geographic coverage, because EDGE is a global tool. It's used all over the world, and so we needed data sets that covered all these different global regions. As I've said before, the LCA scope for this project is what's shown in this grey box. So that's all of modules A to C embodied carbon. Whereas EDGE version 4 will cover everything in the purple box, which is upfront carbon. In terms of standards alignment, so at the product level, in terms of when we're carrying out calculations for individual construction products, this is aligned with EN 15804, which is basically the main kind of standard that's used for construction environmental product declarations. And then at the building level, we've aligned with the Royal Institution of Chartered Surveyors Professional Standard on Whole Life Carbon Assessment for the Built Environment, second edition, or RICS-PS as it's more widely kind of known, or in short. And essentially both these standards are kind of considered industry best practice. As I said, we've covered these 4 materials: concrete, steel, timber, and bamboo. Concrete is basically the most used construction material on Earth by volume. The only material that humans actually use more than concrete is water, so really significant. It accounts for around 7 to 9% of global CO2 emissions, and really it's the cement or the binder that holds concrete together that's the most carbon intensive part. Steel is, as we know, used a lot in building construction, particularly in the form of steel sections, of which there are many varieties, and rebar and tendons and things like that. It is highly carbon intensive per unit mass, but it is also very strong. And as a general point, I'd say that I'd really caution against comparing these materials on a sort of kg by kg basis to one another, because they are very different in terms of their kind of engineering and structural properties. Timber is a potentially lower carbon bio-based material. One of the key things that most people know about timber is that it stores biogenic carbon as it grows, but then that biogenic carbon is normally released again at end of life. And then bamboo, similarly to timber, it is potentially a lower carbon material. It stores biogenic carbon as it grows, but in contrast to timber, the widespread use of bamboo is still somewhat limited, but we're hoping that by sort of including it in this work, we can help to facilitate sort of expanded use of bamboo. So as I said, one of the key requirements was for these embodied carbon estimates to be relevant to the kind of various global regions that the edge users operate in. And so what we've done is produced region-specific data sets for these 7 regions. So that includes the Middle East, Africa, Europe, Central and South America, Oceania, Asia, and North America. And for this study, most of the data sets that we produced are at the region level, but in some cases we have provided data also at the country level for where kind of production of the materials is more kind of localized. And we do recommend that kind of future studies could expand the database to include even more country level data sets. So moving on to the next slide. So this slide has quite a lot on it, so I'm going to spend some time going through it. So first of all, you see at the top in concrete in grey is concrete, and we've included both ready-mix concrete as well as precast concrete. We've included both sort of conventional Portland cement-based concretes as well as various concretes that contain SCMs, or supplementary cementitious materials. So these include ground limestone, GGBS, also slag, fly ash, and calcined clays. And we've also included a range of strength classes from C810 up to C5060, which is kind of the typical range of strength classes that are used in building construction. And I just note that you know, in some other regions, different strength class notations are used, and so all the data sets that we've developed will have strength class notation, both in the units that are used, for example, in UK and Europe, but also the units used in other places, for example, imperial units that are used more commonly in the US. One important note that I want to make is that these SCMs can't entirely replace clinker in cement, but they can significantly reduce the amount of clinker and therefore reduce emissions. And I'll get more onto kind of how much they can reduce emissions later on. For most types of concrete, we've covered all global regions, but then for calcined clay-based concretes, where production is kind of more localized, we've got one data set basically for each country where calcined clay is produced at significant scale. So next in blue, you see steel, and we've got a range of products here. So rebar, steel open and closed sections, plate, galvanized steel sheet, light gauge framing, and post-tensioning tendons. And essentially what we've done is provide one data set for each region. Timber, similarly, we've got a range of products. So we've got sawn timber, both kiln and air dried, particle board, MDF, plywood, and glulam. And then for bamboo, we've included bamboo pole. We've included data sets for several countries, basically where bamboo is produced and for which data is available. And then we've also included a kind of global data set to cater to countries where perhaps bamboo is being used, but where we weren't able to get kind of the data. So we've got global coverage there too. And I want to touch on our approach to resource-constrained materials, because this has been really fundamental in shaping the way that we've selected the different materials for this project. So, you might ask, what are resource-constrained materials? And basically, they are materials where supply is limited and doesn't readily increase to meet rising demand. So the kind of two that are most important to this project, firstly, steel scrap, which you see there on the top left. And the key thing to know here is that pretty much all steel is recycled at the end of life, but then there's only enough scrap steel to replace about 1/3 of demand for new steel. And so, as I said, demanding more recycled steel won't necessarily mean an increase in supply. And then GGBS, that you see that on the bottom left. Basically, this is a byproduct of blast furnace iron production, which is in itself a carbon-intensive process. And basically, there's only enough GGBS to replace about 8 to 10% of Portland cement clinker production globally. And then the actual supply of GGBS is likely to decline into the future as this blast furnace iron making process is phased out in order to achieve net zero. And so I guess the kind of key takeaway from all of this is what it says in the orange box, which is that using more resource-constrained materials on projects usually results in those materials being transported to where they're in highest demand, rather than more being produced. And this helps to reduce emissions on projects that use them, but does little to reduce emissions globally. And so what have we done about this? Well, firstly, for steel, all of the steel data sets represent a regional average recycled content. And then for GGBS, we've provided mixes containing up to 50% GGBS, but we really recommend limiting their use to applications in your building where they provide a performance benefit. So for example, in substructure with highly aggressive ground conditions, GGBS may be more beneficial for use, and so we'd recommend using it there, but not purely to just reduce carbon, but as a way to kind of get better performance. And all of this kind of philosophical approach to resource-constrained materials broadly aligns with guidance from institutions like the IStructD. So the other thing that we've done, as I said, is to update construction assemblies available in EDGE. So we've updated the EDGE materials reference guide, which contains all of these assemblies. And basically what this guide does is to tell you what building products go into each assembly. So for example, you see on the screen here that concrete and rebar and plywood go into producing an in situ reinforced concrete slab. And so the idea is that EDGE users will be able to define what assemblies they're using for their building and also define their dimensions. And then out of this will come the material quantities, which are then combined with the carbon factors we've developed for the study to then calculate upfront carbon in EDGE version 4. One of the key things that we've done during this project is to expand the scope of the structural building elements in the guide. So in EDGE version 3, the focus was mainly on upper floors, which you see in orange in this diagram, and the roof structure, which is gray. What we've done is added substructure, which is the blue, and also vertical frame elements in yellow. So that's things like columns and concrete cores and stability systems and the like. And I'd really encourage anyone using EDGE to refer to the EDGE Materials Reference Guide updated version that you see on the screen. All right, and moving on to study findings. So I'm going to just talk through the kind of overall structure of this section. So basically, I'm going to start by stepping through the embodied carbon emissions from the production of concrete and steel and timber and bamboo. So that's modules A1 to A3. And then I'll talk about the material transport to site, which is module A4, and then I'll talk about site emissions. And basically what I'm going to present is, first of all, the kind of key results from the embodied carbon estimates study, and then a little bit on insights on how to reduce embodied carbon. But I do want to kind of point out that the insights that I'll present on this webinar are really just a kind of high-level summary of the much more detailed guidance that we provide in the EDGE training materials that we've developed for the study. So I'd really encourage EDGE users to kind of refer to these training materials and particularly to get the design and construction teams involved in the process of designing lower carbon buildings early on. And I'll start with concrete, and just to give some context to kind of concrete's emissions and the different terms that I'll be using. So globally speaking, concrete accounts for about, as I said, 7 to 9% of global CO2 emissions. And most of conventional concrete's emissions come from the cement, which, as I said, the kind of glue that holds the concrete together. Whereas actually most of concrete's mass is aggregates like sand and gravel that are actually bound together by cement. And then conventional cement is usually made of around 95% clinker and 5% gypsum, which is kind of added to control setting. And then for conventional cement, most of these emissions are the process emissions that come from the breakdown of limestone or CaCO3 into lime, calcium oxide, and CO2 during production. And then really it's the calcium oxide, which is the kind of key binder that or reactive element in the cement. And then most of the rest of the emissions come from fuels used. So these are things like coal and natural gas, waste fuels, biomass that are used to heat up these raw materials to around 1400 degrees Celsius in a cement kiln. And then the remainder comes from things like electricity use and transport of materials. And so this graph is showing the emissions related to Portland cement clinker. And just before I kind of dive into these graphs, I just want to kind of explain how they work. So along the x-axis, you have the different materials and regions. Obviously, this graph is for Portland cement clinker, and you can see the different regions, so from Africa, Middle East, through to Asia. And then on the y-axis, we have the embodied carbon and kg CO2 equivalent per unit of material. The unit differs slightly, so we use cubic meters for timber and concrete, and then kilograms for things like steel and bamboo and cementitious materials. So here it's kg CO2 equivalent per ton of clinker. And then the bars are segmented according to basically where the emissions come from, and I'll talk you through those. But basically what this graph is showing is that, you know, for Portland cement clinker, most of these emissions are from the kind of breakdown of limestone to lime that I talked about earlier. And then most of the rest come from fuels used to heat the material. So that's what you see here. And what you'll notice from this graph is that Europe has the kind of estimated lower emissions clinker, and that's basically due to higher rates of both biogenic and waste fuels that are used to produce cement. Whereas in contrast, for example, Asia, based on the data we have, uses mostly coal and petroleum coke to produce clinker, and so that's why the emissions are higher. And this graph is showing the emissions from cementitious materials. So this is things, so clinker is in gray, GGBS in purple, fly ash is yellow, ground limestone is blue, and calcined clay is the orange. And I guess the key takeaway from this is that basically all the SCMs that are included here are significantly lower carbon than Portland cement clinker, but they can't entirely replace clinker in cement. So for example, ground limestone can be used up to about a 15% replacement before the kind of properties of the concrete start to deteriorate. So you are limited in terms of that replacement rate. Another thing I'll point out is the differences in emissions from GGBS, which is the purple, in different regions. It's higher, particularly in Africa, and this is due to basically less iron production in this region, meaning further the material needs to be transported further. Another thing you'll note is that several African countries, so for example, Ghana, Ivory Coast, Angola, Burkina Faso, these all produce calcined clay. And so I'd really recommend that edge projects in these countries look at using this material, as it is a kind of scalable, lower carbon alternative to clinker and to resource constrained materials like GGBS. And so this graph is showing the emissions of the actual concrete mix with all components, including sort of aggregates and admixtures. What you see on this graph is that you have conventional sort of Portland cement-based concretes here. So you have sort of C3240 ready-mix concretes. These are C3240 precast concretes, and then everything to the right of this is different types of SCM-containing concrete. While this graph just shows C3240 mixes, because we've got hundreds of these different mixes that are available to select from. If I did show the different strength classes, what you'd see is that basically the emissions of concrete is mainly driven by the cement content, because as I said, cement is kind of the main emissions containing part of concrete itself. And so I guess the first key message is that the binder content is the main driver of emissions. So really look for ways to use cement efficiently in concrete. And then secondly, as you can see from the graph, higher SCM content generally means lower carbon concrete. So also definitely look to use SCMs to reduce the embodied carbon of your concrete. So in terms of concrete, how can embodied carbon be reduced? And I guess the first thing is to design efficiently, while of course still meeting your kind of codified engineering requirements. Second thing is to design concrete mixes efficiently to use less cement. Third is to use low carbon SCMs like calcined clay, ground limestone slag, and fly ash. Fourth is beware of over-relying on resource-constrained GGBS. And then finally is to source materials locally. Often I get asked, who's responsible for each of these kind of parts of reducing carbon, and the answer is many people. You have the structural engineer, the concrete technologist, concrete supplier, the contractor, all involved. And so really the key takeaway and the point I want to make here is that is to get designers and contractors involved in this process of reducing embodied carbon early on, and we've developed the training materials to help and kind of support this process. And this applies not just to concrete, but to kind of all the materials in the study. I also wanted to draw attention to the hierarchy for net zero design. Basically what this says is to start by thinking about how to use less material through things like retaining existing building elements and designing efficiently before thinking about how to kind of specify lower impact materials. And again, this applies not just to concrete, but to all the materials in the study. So next I'll get onto steel, and what this graph is showing is the embodied emissions of steel, again by product and region. So we have rebar here on the left, open sections, closed sections, plate, light gauge steel frame, steel sheet, and post-tensioning tendons. I think probably what stands out most is the really wide range in embodied carbon, both between regions and across the different types of materials. The variation is driven by kind of three main things. So the first is the balance of electric arc furnace and basic oxygen furnace steelmaking. And then relatedly, the second thing is the recycled content or scrap use in steel production. And generally speaking, electric arc furnaces use a lot more recycled steel scrap, and basic oxygen furnaces tend to use much higher rates of virgin iron. And then the third thing that is really important is the different carbon intensity of electricity, particularly when you're using electric arc furnaces to produce the steel. And in terms of the embodied carbon between products, mainly the differences are due to the differences in these three factors. So for example, rebar in general is produced more commonly using electric arc furnaces compared to, for example, steel plate. But then you also do have emissions differences driven by differences in kind of downstream processing emissions. So that's what's shown in purple. But really, the big thing is that those three factors that I talked about previously. So how can carbon be reduced? First thing, again, design efficiently to use less steel. That's probably the most impactful thing you can do. And I would say that using higher recycled content or sort of EAF steel can send a positive demand signal for low carbon products. But again, really beware of over-relying on resource-constrained scrap steel to reduce emissions, as this will help reduce emissions on your project, but not necessarily at a global level. For timber, so this graph is showing, again, the emissions intensity of timber by product and region. So we have sawn timber, kiln-dried sawn timber here, air-dried sawn timber here, particle board, MDF, plywood, and glulam. I guess the main takeaways from this graph, first of all, generally more processed timber products are generally more emissions intensive. So things like particle board, MDF, plywood, more carbon intensive than air-dried sawn timber, for example. And then the other thing that stands out is that you see that these purple bars here are resins, and they are also quite a significant contributor to the emissions from timber products. And then the final thing I want to point out is that timber is very much a traded product. So what you see is that the bars that you see on screen, these represent in-region production of timber, but then the actual final figures that would be used as the kind of baseline values in EDGE are these regionally adjusted values that are shown by the black dots. So for example, if you had in Oceania 50% of the timber coming from Oceania, 50% from Asia, then that carbon factor would take a kind of 50-50 weighted average of the production factors for those regions. So just bear that in mind. And then finally, bamboo. So this graph is showing, again, the emissions of bamboo pole by region. The key thing here is that the chemical treatment stage, or these purple bars, are the kind of most carbon intensive process according to the data we have. But then harvesting, transport, and washing are also important. But generally speaking, bamboo is quite a low carbon material. The supply chain is quite short. And so, yeah, it's fairly low carbon material. For timber and bamboo, how can carbon be reduced? Firstly, I would say as a general point that using timber and or bamboo is likely to be a significantly lower carbon than using conventional materials like concrete and steel. But this really will depend on your project, and it should be checked and not taken for granted. Secondly is to make a point of designing for durability and fire resistance to achieve a long lifespan for the timber products. And then finally, sourcing locally, because with timber, it's a product where typically the kind of production emissions are fairly low, but it can often be transported quite long distances. And actually, so for the kind of upfront carbon of your timber product, transport can be really a significant proportion of the total. So make sure to take those transport emissions into account. And also, I want to say that biogenic carbon is not going to be counted in EDGE version 4 because it's just going to have an A1 to A5 scope. However, it is really important still to firstly check that timber is sustainably sourced, because otherwise, in a full A to C LCA, the biogenic carbon storage would not be able to be counted, whereas the release of carbon at end of life would be counted. So this would be really, really bad for the emissions intensity of the material. And then secondly is to check that timber is disposed of responsibly at end of life. And generally speaking, sort of uncontrolled landfill, for example, releases a lot of methane emissions, which really pushes up the whole life carbon of the timber products. You really want to avoid that kind of end of life process if you can. Next, I'm going to move on to transport to site. So this graph is showing the energy intensity of different transport modes that are available to be selected from an EDGE. And this is just a kind of selection of the modes available. There is a kind of longer list. But I guess the key takeaways from this graph, first of all, that road is much more energy and carbon intensive than sea and rail. And generally speaking, kind of larger, more heavily laden vehicles have lower emissions. All other things held constant. And then this graph is showing the emissions intensity of the actual fuels that can again be selected for an EDGE. And the key thing here is that it's important to consider both the kind of well to tank emissions, so that's these red ones, which is everything related to the extraction and processing of the fuel to get it into the vehicle, as well as these tank to wheel emissions, which are shown in purple, which is basically the emissions from actually burning the fuel in the vehicle. And the important thing to know is that both of these things are counted in EDGE, and it's important to do so because you see, for example, for hydrogen, it doesn't release any emissions when you combust it in your vehicle because it just releases water, not CO2, but the actual emissions from producing that hydrogen from natural gas, for example, are really quite high. And so how can embodied carbon be reduced? So the first thing is to source materials locally. Obviously, that helps to reduce transport distances. Second is to input the actual transport distances into EDGE models rather than relying on default values provided. And so on this point, basically what we've done is to provide sensible default values for each material and region. And this is to kind of make the app as user-friendly and as accessible and simple as possible. But we need to be realistic about the fact that these default transport distances can't represent every project. Every project will have a different sort of proximity to production facilities for the different materials. And so to get the most accurate answer out of your EDGE models, you will want to kind of enter the actual transport distances. Thirdly is use lower carbon transport modes, and then finally use lower carbon transport fuels. These are all good ways to reduce emissions. And then finally, so this graph is showing the default kind of regionalized construction site emissions by region. And as is probably expected, most of the emissions we expect to come from the electricity, which is the red, and diesel use, which is in purple on the site. And just to summarize the kind of key outputs of the training materials, so we've tried to condense everything into the kind of 10 guiding principles for how to reduce embodied carbon of structural materials. So the first one is to engage with the design team and contractor early to explore structural carbon reduction options. And I'll just note that the little symbol there on the left that you see next to the number is there to kind of indicate where professional engineering input is really especially critical to make sure that the structures are designed to be compliant and safe. The next point is to retain and reuse existing building elements and enable the same at end of life. The lowest carbon option is almost always going to be to either not build anything or to retain much of what's already there on the site, if that's possible. Third is to optimize the design of structural assemblies and concrete mixes. I mean, I've shown that really the binder content of your concrete is really important, and also just designing your concrete elements to use as much material as is needed and not more. Fourth is design for durability and fire safety in accordance with the applicable standards, particularly critical for things like timber and bamboo. Fifth is to procure bio-based materials like timber and bamboo from certified sustainably managed sources. Sixth is to factor in the transport to site emissions when considering alternative materials. As I said, this is going to be especially important for things like steel and timber that can often be transported very long distances from the construction site. The next one is to consider the end-of-life treatment of bio-based materials. As I said, really avoid uncontrolled landfill. Things like incineration, reuse, recycling of timber are much better in terms of controlling the end-of-life emissions. Eighth is to consider alternative binders for concrete. Do consider using SCMs to reduce the amount of Portland cement clinker in your concrete. Ninth is to beware of over-relying on resource-constrained materials. As I've said, GGBS and steel scrap are the main kind of ones that apply for the building structure. And then finally is always bear in mind that you should be considering the whole life carbon of the whole building when comparing carbon reduction options. So that brings me to the end of the results section. And as I said, I'm just going to briefly touch on kind of next steps. So the immediate next steps, first of all, as you can imagine, we want to make sure that these product level data sets and assemblies will be made available in Edge version 4 for calculating upfront carbon. And then, as I mentioned, we've provided guidance both for sort of how to reduce carbon of structural materials on projects, and also guidance on the actual structural assemblies that can be selected from in Edge. And then finally, recommended future developments. So the first key thing that we've recommended is to establish a regular update cycle for these embodied carbon estimates. Obviously, embodied carbon is something that changes all the time. It's not fixed. For example, as soon as the carbon intensity of the electricity grid changes in a given region, that's going to have a flow-on impact on all these data sets. And so it's going to be really important that they're regularly updated to keep them relevant. The second thing is to add other high impact materials. So as I said, we've covered concrete, steel, timber, and bamboo, but other materials like bricks, glass, and aluminium should be added in the future using a kind of comparable methodology to what we've done for this project. Third thing is emerging technologies. So we've mainly just covered technology, materials that are available now, but emerging technologies like clinker production with carbon capture and storage, lower carbon primary or virgin steel production, calcined clay and bamboo in regions that they aren't already produced in. These will all be added as they become available in the future. Fourth thing is to expand to a full life cycle calculation. As I've said, Edge version 4 will just cover sort of upfront carbon, but with these data sets we've developed, future versions of Edge could expand to the full life cycle. And then finally, is to gather more sort of producer-specific and potentially country-specific data. And basically the model that we've developed to estimate embodied carbon for this project could be used as a framework to collect this data going forward. And so that brings me to the end of the kind of formal presentation. I'll now open up for Q&A.
Much, Matthew. Thank you very much for your session. And as usual, every time we have these discussions, I ended up learning many new things. So thank you very much. I think so. We have a few questions, and I have one specific for this panel of experts that we could cover. So as context for everyone, so the work that Arup and team are doing is for us to determine the baseline for the different regions. So it's based on what we call data sets, which is not product specific, but it's an average of the region. And there are some factors accounted across the different regions to calculate that average. The question that we hear, and there is a question on the chat, is what are the steps that a manufacturer could take to then demonstrate some improved performance in terms of embodied carbon for the specific projects during the assessment of EDGE version 4, for example, in the future. So we have some very basic guidance as to how to create custom materials, but we want also to improve and to make sure that we are capturing best practices out there. So from your perspective, and even from Jane as well, if you want to jump in, but
Yeah,
what are those
maybe
best practices that,
yeah, I think the key thing here, if we're talking about improved embodied carbon performance for a particular product, so let's say it's a steel rebar, the best thing to do is for that manufacturer to produce an environmental product declaration for their product, which will represent as accurately as can be done the emissions associated with that product. And my understanding is that EDGE will have the ability to kind of take in that product specific or producer specific data to kind of replace the default factors that we've provided. So yeah, I'd say get an EPD is the kind of main next step for that. Yeah.
Excellent. Yeah, good. So the other question, and I can address that one, is that related to version 4 and how it is more aligned now with RICS second edition, like whole life cycle assessment second edition. This alignment is giving us a lot of benefits, which means, for example, that we speak the same language when we are discussing outputs about this study, and then how it will be integrated in EDGE version 4. But it also will enable users to take studies, validated studies or analysis from third-party software, for example, and then use those results directly within the EDGE app. So I think that's good news for users. I can see questions related to the use of the EDGE tool for different applications, some of them EU related or regulation related. So yeah, the good news is that there will be more alignment with the standards, meaning that it can be used in a wider range of applications. Okay, so I have another question over here. So how have you included or considered particular manufacturer claims of green cement at regional level? And it says, I believe these are quite different between manufacturers. What are your assumptions for lifetime of materials?
Yeah, so for most of these materials, we haven't gone and collected primary data about the production process from manufacturers. We've used generally kind of global data sets that have information about, for example, the different fuels used by cement producers in each region, things like the location and type of steel plants that are used for steel production, and we've come up with our own estimates for that. So it's I would just say that we've developed our own estimates, and no one supplier has necessarily swayed kind of what the estimate would be for that region. It's all based on kind of consistent global data. So hopefully that answers the question.
Can I come in as well? So I think if you see sort of claims from manufacturers, again, it's similar to the previous question. You know, as a manufacturer, we would recommend you get an EPD. If you're looking at claims from manufacturers, you know, check that it is an EPD from a EPD program, that it's been verified independently, and have a look at the claims to see, you know, to what extent it might be relying on, you know, use of guarantee of origin, for example, for low carbon electricity production, or maybe mass balance claims, use of things like biochar to reduce carbon, some of which are not allowed in a lot of EPD programs. So it's just being aware the EPDs should be transparent and they should be verified so that you can make comparisons.
Excellent. Thank you very much, Jane. I have a question regarding to the increased scope of EDGE and the potential additional burden in terms of documentation that will require for transport emissions, for example. So here I can answer these calculations. They will come with educated guests defaults, for example. So users that don't have the information will always have the option to leave the default assumption unless they have the evidence to support different the different transportation distance, for example. So this shouldn't be seen as a additional burden. And this study comes with country level transportation average per products. It's a very comprehensive study that our colleagues from Arup have provided. So the idea is that following the philosophy of EDGE, if documentation doesn't exist, we have an educated guest that can be used to go through the certification. I think that that's an important factor to consider. And then also questions about the materials guide. So the materials guide that existed for EDGE version 2, and then we remove for version 3, will come back in version 4, reloaded with all the materials and all the assembly information. Once that's ready, we will be happy to publish it ahead of the release of EDGE version 4. Hopefully during summer 2027, we will be able to publish the documentation for EDGE version 4 for the different project teams to be prepared and to be informed as to what's coming in terms of EDGE version 4. So we are preparing for it, and we will be happy to share all that information with our entire user base. Question for the team here from Anna. For countries with high seismic or hurricane design, will the baseline structural assemblies in EDGE account for the additional structural materials required by local building codes? For example, increased reinforcing steel, larger structural members, or additional bracing. Otherwise, how will the methodology ensure that embodied carbon and benchmarks remain comparable across regions? So this is a very important question. I think maybe, Matthew, if you can speak a bit about the initial guess, well, the initial assumptions that we will have for the default values in terms of columns. If you could speak about that, which will be used as the starting point for the base case, and then will be fine-tuned per region. Well, that part I can.
Yeah, so as far as I understand, at this stage, we haven't gone into that level of detail of, you know, country by country doing a specific design for each assembly and for each country. We've provided, yeah, as Alberto says, sensible default values for a given assembly that EDGE users can then refine. I would say that, you know, seismic codes obviously are important, but there are many factors that are going to determine, you know, the thickness of columns or of floor slabs. You know, things like the building height, the spans. You know, that there's many different factors, and so we can't. It's not going to be practicable to kind of apply or to develop defaults for every single potential application you could have in a building. So I think that is going to be an ongoing challenge to kind of continue building more default values, or more kind of refined default values for each assembly, for each region, for each structural application in the future. But at this stage, mostly it's kept at a pretty high level where we've got sort of one default value for each assembly. So hopefully that answers the question.
And to complement that, the current allowance in Edge version 3, we will also move it to Edge version 4, where with the use of built-in resilience index, it will be possible to prevent any potential penalty in the improved case due to resilience considerations. So while we fine-tune the baseline, we also have this kind of a workaround as well, where we might not provide savings in those cases, but we make sure that there is no penalty considerations as long as they are justified under the resilience and hazard mitigation criteria. And that's how the relationship with Edge and BRI becomes more important than ever, now that the scope of embodied carbon includes foundations and includes frames. It is important to make sure that resilience considerations are included, justifiable, and just to answer one of the questions, so BRI is a standalone tool. It can be used for Edge or for any other certification or on its own. But from the Edge version 4 perspective, the assessment, the resilience assessment will be required as part of the certification process. More information to come. We'll have a dedicated webinar for that. But as you can see, the 4 pillars that we presented at the beginning, they are connected. The cost calculation uses this study. We are pricing each of these elements that the Arup team has provided. Also, then resilience consideration also come into the picture when it comes to seismic zones. There's a question for Elaine, probably. Elaine mentioned that the MAGC program's already been rolled out in several countries, including South Africa and Philippines. Are there plans to expand the program to additional countries across the Global South? And if so, what's anticipated timeline? Furthermore, project located in countries where the program has not yet been introduced, what mechanisms or pathways are available for developers to access MAGC funding? Maybe it's Elaine, or can we have a high-level discussion on this one?
Yeah, I'm wondering, I think, Alan, you already put your video on. I think you can talk on this, but maybe just to clarify. So I was talking about the MAGC research program, which covers on a subset of up to 13 countries, but the MAGC program overall covered, I think, 23 countries. Alan, you could probably come in and talk a little bit about the expansion and the plan going forward.
Yeah, of course. So there's been active work across 24 countries, but the Edge tool is used in over 170 countries. So it's sort of already widely adopted, and it's possible for people to use the Edge tool without the kind of dedicated funding. We do have plans underway to think through the future of MAGC, and that future funding would likely focus on DESNZ priority countries, which tend to be sort of middle income, or it tends to be markets where we can bend the emission curve the most. But yeah, any kind of future discussion on that is subject to further internal approval.
Absolutely. Thank you very much, Ellen and Elaine. Back to the Arup team. On the lifetime assumptions, what is the assumptions you have used? Because these might be different for different materials. Yeah, just to mention, the main information we were using for Edge version 4 is A1 to A4, which is which does not involve lifetime assumptions for materials, but the team has done studies for the full life cycle assessment. So over to you, Matthew or Jane.
Yeah, so as you said, I mean, the lifetime of a material will mainly feed into module B4, which is replacement. So for example, if you had a building material that only would last 30 years rather than the full kind of 60-year reference study period, then you would have a kind of replacement cycle halfway through the building's life, and that would increase module B4 emissions. this project, yeah, it's well for Edge version 4, as Alberto said, this covers modules A0 to A5. It doesn't include the in use and end of life, so that this isn't so relevant. But we have included in the background some kind of default lifespans for materials. But generally speaking, these are structural materials that are expected to last the kind of full 60-year reference study period for the building. I don't think, yeah, and essentially they, you know, this kind of assumes that the building structure has been designed according to codes and kind of with durability in mind. But generally speaking, it's we would expect all these materials to last the full 60 years.
60 years, yeah. And also we are using cost assumptions. Sorry, somebody?
I was just going to say, I think some of the timber board products, depending how they're and where they're being used, you wouldn't necessarily expect them to last that long.
Yeah, true. And we have a table, right, of assumptions for each of these materials. So absolutely, that's something that has been considered. There's a question here. Many projects involve the demolition of an existing building. Are the emissions due to demolitions being included? And then there's a note. Often remodeling a building often remodeling a building instead of, I believe, going for a wood design can reduce emissions significantly. I believe that's what we meant to say. So what is our stance on the demolition emissions?
Yeah, so we've made and we've provided a default value for, this is called LCA module A5.1. So this is pre-construction demolition, and we've provided a default value for these emissions, which is I think around 30 or 35 kg per square meter GIA, which is based on RICS professional standard. So that would be factored in if there's an existing building on site that's being demolished. Yeah, so there's a allowance for that. Oh yeah, go ahead, Jane.
But I mean, basically, the main benefit of it's not to demolish buildings, to make use of them and then reduce the amount of new material you need in the building. So, yeah.
Absolutely, absolutely. I believe we have covered most of the questions. Please, anybody help me to see if I missed anything?
I think there was a last question.
The last question,
Edge versus other certification systems. Did you see that? Unfortunately, how does the Edge system distinguish itself from other green building certifications, such as LEED or WELL, in terms of its core metrics, target markets, and verification process?
Oh, yes. So this is a very good question. So Edge, it's a certification that has its core focus on the efficient use of resources, be it energy, water, or materials, and then making sure that those resources are used in a resilient way. And that has been the core focus of the definition of green buildings for World Bank Group and many multilaterals. And this is why EDGE programs was created as a response to that definitions from IFC and World Bank Group. LEED certifications, for example, they have a broader set of criteria, which includes human comfort and other aspects, which are quite important as well, and they have their value as well. So EDGE, if you want to think of the resource efficiency exclusively, then EDGE has been designed for that, and LEED will look into that, plus other different dimensions of sustainability. They all have their value, and many times portfolios have a combination of different green building certifications. We are in constant communication and collaboration with our friends from LEED to make sure that the metrics are similar and comparable over time. So that's something that we are working on continuously. And yeah, and in terms of target markets, traditionally EDGE has been the tool to that helped markets where they are not very familiar with green building, we are providing them with an initial benchmark to beat. For example, this embodied carbon can be used or is in practice being used as a benchmark for national targets in many places where there is not even one. Some countries will have their national targets. Denmark, I believe they have. Some provinces of Canada, they have national targets. In practice, EDGE provides this kind of a platform to create an initial benchmark to start making educated decisions in especially emerging markets. I hope that answered the questions. And yeah, there's the last question here. Can I do LCA calculations through the EDGE software? So we are working on it. Version 4 will give you much more capabilities to have more flexibility on how to do the LCA. It will not be whole life cycle, as we have been saying during the call, but we are working to make sure that if you have additional information about the calculations, they can be provided to the app, and they can be used for reporting purposes. EU taxonomy, for example, for buildings over 5,000 square meters will require the disclosure of whole life cycle assessment. So EDGE version 4 will enable users to report additional components beyond the certification scope, but we want users to use the app as part of this disclosure requirements from different jurisdictions or countries. Yeah, hopefully that answers that question. And if there is nothing else, want to ask our panelists if there is any comments.
If I can add something here,
yes.
If I may. Thank you. So one question that you asked about the other green building certification systems, I want to make sure that we share this point with everyone, that the MAGC funding is available for all green building certifications, that they follow standard requirements in terms of quality of the audit and resource efficiency. So LEED, BREEAM, and DGNB, other certification systems, the ones that qualify for MAGC, they all can enjoy the benefits of MAGC investments. So our financial institutions, Ellen mentioned the investments that we have done, almost $3 billion of investments through financial institutions. They all include all certification systems. So that's really important that the certification systems qualify for green mortgages, for green construction finance. And obviously the differences that Adel mentioned, they are valid differences. But in terms of the availability of finance, the support is provided. Back to you, Adel.
Thanks very much, Smith. Thank you. Yes, very important note. I believe we have answered most of the questions. People are asking if the video and the slides will be available. We'll be post this video in the EDGE Buildings channel, and we will distribute the slides to the attendants. And we have a large number of attendants, so we're very happy for that. Thank you very much. Any final note, Elaine, or from our panelists?
Just one thing before closing. So I think Elaine might have already posted something in the chat, but we'd be really appreciative if you could scan the QR code and fill in the survey to give us feedback on the webinar, because obviously it'll help us to kind of improve, or help IFC to improve the quality of these types of sessions in the future. So yeah, please do take a moment, and I'll leave that on the screen. But yeah, nothing else from me. So back to you, Alberto.
Yes, excellent.
I just wanted to take just a second to thank Matthew and the whole Arup team for this great work and really fantastic presentation today. So thanks a lot for the amazing collaboration over the last years and months on this. Thank you.
Yeah, likewise.
Yes, it's been over a year more in continuous discussion. So thank you to everyone involved. Janice is here as well. She's been instrumental on this. So thank you, everyone. Have a good rest of the day, and thank you for attending today again.
Thanks, everyone. And thanks
Thanks,
for
everyone.
taking a minute to fill out the survey. Really much appreciated. Bye.